Hello and welcome to another instructional video from Cortigo. Today we will be discussing how to configure a Tigo Hub. During this video we will use the TigoHubi4 2, but this procedure is very similar on the original Tigo Hub i4. When configuring the Tigo Hub, one should keep in mind that the main purpose of the configuration is to build the data stream being sent or received to/from the wireless master and Tigo Hub. During configuration, we will set the data length of each port, set the index of each port, and set the type of data on each port, i.e. digital or IO-Link data. Before we begin with real-life examples, we will summarize the two examples from the Tigo Hub's user manual. In this first example, I will show you the data stream for only processed data outputs. In this example, the Tigo Hub has 32 bytes of total processed data outputs, and this will come in the form of 14 bytes of IO-Link outputs on port 1, 7 bytes of IO-Link outputs on port 2, 2 digital outputs on port 3, and 10 bytes of IO-Link outputs on port 4. As we can see from the image below, the offset of the port determines the location of that port's data in the Tigo Hub's data stream. We can see that port 2 has an offset of 0, so it begins the data stream starting at index 0 to index 6. It's then followed by port 4, which runs from index 7 to index 16, and then port 1 ends the IO-Link data from index 17 to index 30. As a keynote, the digital I/O, regardless of which port they are located on, are always placed in one byte, and that byte is always the most significant byte. Another point to consider about digital I/O over IO-Link. All of Cortigo's products allow for users to configure pin 4 of the IO-Link port to be IO-Link or digital I/O. Pin 4 is also known as the CQ pin. Some Class A IO-Link also allow pin 2 to be used as a digital input or digital output. This pin is known as the IQ pin. The mapping of the digital data is laid out as follows. The CQ pins for ports 1 through 4 are the 4 most significant bits of the digital byte. They are followed by the IQ pins for port 3 and 4, and then the last 2 bits of the digital byte are reserved. In this second example, we have 2 bytes of IO-Link inputs on port 1. Then port 2 has 1 digital input. Then port 3 has 3 bytes of IO-Link inputs, and port 4 has 1 digital input. From the image below, we can see that port 1 starts the data stream at index 0. Then at index 2, port 3 has 3 bytes of IO-Link inputs. And lastly, both ports 2 and port 4 have 1 digital input, both of which go in the most significant byte. In our live example, we will use the following hardware. Port 1 will have an IO-Link distance sensor with 3 bytes of inputs and 0 bytes of outputs. Port 2 will have an IO-Link stack light with 0 bytes of inputs and 7 bytes of outputs. Port 3 will have an IO-Link color sensor with 2 bytes of inputs and 0 bytes of outputs. And port 4 will have a simple digital input. Let's see how we configure these settings inside TigoEngine. Before beginning the next portions of this guide, users should integrate their Tigo Hub's IODD file into their TigoEngine. Our Tigo Hub's IODD files can be found on the customer portal on our website. First, we're going to log into TigoEngine. Then, select our desired wireless master and select our Tigo Hub. Then we'll go to the Device Configuration tab and click on the Get All button. This feature collects all the Tigo Hub parameters so that we can view what was already configured on the Tigo Hub. Then we'll navigate to Tigo Hub Parameters, then Configurator. This is the menu we will use to configure all of the wired ports parameters, as well as the parameters for the Tigo Hub itself. First, we'll go into the wired port 1 parameters. Here, we have an IO-Link distance sensor connected. The wired IO-Link PDN length is 3 bytes. Since we want this data at the beginning of the data stream, we will set the wireless IO-Link PDN offset to 0. For this example, the wired IO-Link PDN port offset will also be 0. But we'll explore this option in the next example. In the next settings, again we are asked for the wired IO-Link PD length, but this time it's on the output side. Our distance sensor has no outputs, so we'll put a 0 here and a 0 for the wireless device PD out offset.
Then we will set the CQ port mode to IO-Link. The CQ mode controls the behavior of pin 4. It can be deactivated, IO-Link, digital input, or digital output.
Next is port 2 with our 7-segment IO-Link stack light. Here, the wired IO-Link PDN length is 0. The wireless IO-Link PDN offset is also 0. And the wired IO-Link PDN port offset is 0. The wired IO-Link PD out length is 7. And the wireless PD out offset is 0 because this is the first device with IO-Link outputs. Now, most importantly, we're going to set the CQ mode to IO-Link. Next is wired port 3's parameters. Port 3 has an IO-Link color sensor attached to it, so the IO-Link PDN length is 2. And the wireless IO-Link PDN offset is 3, which you'll notice is actually the total PDN length configured so far. Since we do not have any outputs, the output lengths will be 0 as well. Most importantly, the CQ mode is going to be set to IO-Link. Lastly, we have our digital input device on port 4. Here, the wired PDN and PD out length will be 0. The wireless PDN and PD out offsets will be 0. And the wired PDN and PD out offsets will also be 0. This is because we have no IO-Link devices connected to port 4. As a technicality, you can either set the wireless PD in offset as 0 or as the correct offset, which in our case would be 5. Then lastly, we'll set the CQ mode to digital input. Once all of the wired port parameters have been set, we will need to tell the TigoHub the aggregated length of the data stream we just built. So we'll go to the aggregated device info tab. And for the input side, we have 3 bytes on port 1, 0 bytes on port 2, and 2 bytes on port 3. Port 4 only has 1 digital input, but since an entire byte of data is dedicated to digital inputs or outputs, this counts as a byte of inputs. So 3 plus 0 plus 2 plus 1 is 6. The outputs are a little easier. You have 7 bytes of IO-Link outputs on port 2 and no digital outputs. So the length is just 7. You'll notice that individual parameters cannot be changed. This is because all parameters in this menu are dependent on one another, so they must all be changed at once. Therefore, we'll use the Save Change button to make changes. When we click the Save Change button, we are allowed to review all of our changes and then hit Save. This was a successful write, and now the TigoHub will be resetting. Once the TigoHub comes back online, we can read the changes using the Get All button.
Next, we are going to do one more example using the following hardware. There's a stack light on port 1, which has 7 bytes of outputs and 2 bytes of inputs. We'll talk about why there's an asterisk next to those inputs later. Then, port 2 has 3 bytes of inputs and 0 bytes of outputs. And on port 3, we have a digital input and a digital output attached to an illuminated push button. And on port 4, we have the same digital input.
We'll start the second example by configuring port 1. Here, we have 2 bytes of process data input and 4 bytes of process data output. However, in this example, let's pretend that the device we are communicating with on port 1 has 32 bytes of process data input. IonLink devices are limited to 32 bytes of process data as a maximum. This limitation affects the Tigo Hub as well. Luckily, we can control the amount of data a Tigo Hub requests from its end device. By placing a non-zero value in the field IonLink PDN port offset, we can grab only the data we want. For example, if I only want the 2 most significant bytes of process data input, I can set the wired IonLink PDN offset to 30. This will ensure I get the 30th and 31st byte of data. For most wired IonLink devices, which send large amounts of data, the most significant bytes of data provide the most useful information. So starting the data stream at the 30th byte is beneficial here. To finish port 1, I will set the CQ mode to be IonLink and then continue to port 2. Port 2, we have 3 bytes of process data input and 0 bytes of output. Note, I will need to place a wireless PDN offset of 2 on this port, and then set the CQ mode to IonLink. Then we'll move on to port 3. Port 3 will have a digital input and digital output for its illuminated push button. In this case, we will make pin 4, the CQ mode, to be the digital input. Then we'll scroll down to the IQ configuration field, and we'll set him as the digital output.
Lastly, we'll set port 4 as the digital input on its CQ pin. And we'll do this by going to port 4 and setting CQ port mode to digital input. And then we will set the aggregated device info. On the input side, we have 2 plus 3 plus 1, which is equal to 6. Notice that even though we have 2 digital inputs, we still only have 1 byte of data dedicated to those digital inputs. On the output side, we have 4 bytes of IonLink outputs and 1 byte for a single digital output. So our total here is 5. We'll hit the Save Changes button, we'll review our changes, and then we'll hit Save. Thank you for watching. If you have any questions, please open a support ticket or email us at support@cortigo.com. Thank you.